Hi everybody, my name is Marius and today, based on requests, I'll be starting a series of small videos and they'll be titled the ABCs of securing the branch edge with a router video 1. Now this will be video 1. If you've seen some of my other videos, you would have noticed what I typically do is I typically first talk about a little bit about the technology, I try and get into it, the basics of it, and once we understand the basics of it, we can then move into configurations. So in video 1, true to fashion that I normally do, I'm not going to delve too much into how to configure it, but more a case of, what does it mean, what's the differences between the types of security you get on an actual a router, why some companies will call their routers firewalls as well, differentiations between them, some of the challenges we see with that. Right, so without further ado, so first of all, what I want to talk about a little bit is basically the overview of the firewall. When I say firewalling, it's a very loose term that's being used in the industry today around securing the edge. Alright, so based on what technology you're looking at, you get a true-fledged firewalls and also next generation firewalls, and for today's purposes it's all about the branch edge. So I'm going to go into a fully functional firewall at the data center edge connecting to the internet. That's not what I'm trying to do. What I'm trying to do by showing you the following couple of things is that you can switch on certain firewalling functions and very easily secure the branch in a very good way. So a couple of things we'll talk about today is the packet filter firewall. Alright, so what is a packet filter firewall? Well, I'll discuss that very briefly with you, and some of the limitations of the packet filter firewall. And some companies out there go and you can set up an access list on the router and suddenly they turn that into a firewall. They call it a firewall in a firewall function. Right, we'll talk about a couple of limitations around that. The next thing I want to talk about is the next step up would be a stateful firewall. Right now that's moving more towards a application based firewall where the actual nature of the application or the packets, the predictability of the packets are possible. Right, moving from a packet filter firewall to a stateful firewall has a cost, and that's CPU, because we're going to have to start looking deeper into the packet to make some predictive analysis about that. Right, the second thing you'll see with a stateful firewall, and I'll explain a little bit later, is that you will actually have a flux access list. It changes based on the outbound traffic. I'll talk about that just now. Then of course you get the zone-based firewall. That's the next level firewall up, and that's where we basically create zones, inside zones, outside zones. The majority of our traffic from the inside out is typically trusted, from the outside in not. So what you try and do is you start to kick off an actual session from the inside out and never the other way around from the branch. Right, so there's no way normally a good reason, or no good reason normally, for anyone on the internet to open up a session inside your network. Okay, there's lots of other things we can talk about, like NATing to secure, of course, your IP addressing. We're not going to cover that at the moment in this configuration setups, but what I do want to talk about is just the firewalling concepts. What I'll be also focusing on today, as it's normal, I'll be looking at the HPE series of routers. Right, the MSR 2K is my base router that I'll be using for this, and I'll be running this from my home lab. So as we move forward through the actual videos, I'll show you a couple of things as we basically enable these functions on the actual HPE router. Right, of course you can use VSRs for this, also an HPE router, and of course they also have the HSR branch, the campus type router. So these are all the functions that support it. So first of all, let's move into the next step here. Okay, if I can get to the next page. There it is. Good, so let's get to the next page. So effectively what we said is a packet based filter. So if we start off by just drawing a little router over here, and I say to myself, well, I've got the inside network and I've got the outside network, yeah? Now the outside network, I'm talking about something like the World Wide Web. I could also be talking about something else here, so like 3G, 4G, whatever type of data connectivity you have on the outside. And you've got the inside type network, which you typically would have your users connected to and devices in the branch. Yep. There are multiple ways to secure the type of traffic across this link with IPsec and so forth, right? But I'm not going to be focused on that right now. What I want to do is I want to look at internet traffic, and let's say the person has, or the branch has, another MPLS link. And what I want to do is I want to switch on firewalling over here somewhere, yeah, to make sure that people don't come from the outside into my network and from there initiate traffic to the MPLS environment. Okay, like I said, we're going to be enabling firewalling functionality, but we have to be careful. So the first thing that we need to do is we can use an access control list, which a lot of companies would do. Maybe I should make that a C, okay, access control list. So you can apply an access control list either in or outbound. This is not what this whole course is about, but effectively in an access list, you get a standard and advanced type access list in general. Yep. A standard access list basically looks at a couple of things. It will look at, for instance, the source IP and destination IP type packets. If you want to get a little bit more advanced, you can also look at the source IP over here, destination IP, but you can also start to predict the source port and a destination port, and you can also look at the type of application in here, right? Not just based on the ports, but other variables as well. Good. Okay, so from that perspective, if you've ever set up an access list, right, it's not that straightforward. Okay, it's easy enough to set it up, but you know what we want to try and do is, let's say we want to actually enable an FTP service from being able from this device A, PC A, to get to the internet, and somewhere on the internet there's an FTP service that we want to use. Right? So if you wanted to do that in an access list, what you would have to do is you would have to start predicting ports. Now you actually have fixed ports and you get variable ports. Right, as we know, anything up to 1024, right, is your fixed ports allocation. Right, we do know that port 21 and port 20 is FTP. Yeah, 23 is Telnet. I can go on with this, you know those. Right, but anything from these ports upward to 65,000 is random ports. Now, a random port is used to set up sessions. If you've seen some of my introduction to networking videos, you'll know everything I'm talking about right now. Okay, because they actually use session pairs. So any packet that fires from the inside out will go with a destination port of 21 and a source port of random port. Right, and that combination of this two would basically give you a session. And that's how we differentiate between different sessions. Remember that in my previous videos. Okay, so that's what this is all about. Now, this is the challenge at the moment because number one, I can't predict the random port. So what we have to start doing is we say, well, we're going to build this big wall here, and we're going to say, okay, access control list. Let's make it 3000. Yeah. Deny IP. Bam. Slam it on there. Inbound. Suddenly what happens is that this packet will be allowed to leave from whatever random port to destination port 21. The packet hits basically the interface and goes out and opens a session to FTP. Right now this guy tries to communicate back, and what happens to this port? Well, access list says deny. So the packet will be dropped. So effectively with an access list like this, I cannot initiate a session. It will always drop the packet inbound. Right, as we said, as it's inbound. That's a bit of a challenge. So what do we need to do? Well, we say, what if we start to predict this? So we're going to say, don't just deny everything. What about if we, I'm just going to change color here. What if we make some good ports? What if we set rule 100, permit FTP coming from a source port. Wait a moment, that's a random port, yeah? So I can't really predict that. So I've got to say source port any going to a destination port 21. So that would work, by the way, because what would happen is the packet would fire out, and I know that purists are going, well, it's going to come back on port 20. Forget about that for 1 second. Okay, what I wanted to focus on is just one session at the moment. Right, so as the packet would come back, it'd say, well, if as long as it fires, you know, with the source destination ports like this, right, we would be fine. But what happens is, because I use the word keyword any in there, this starts to create a bit of issues. It's an actual hole. So what we've just done is we take this big wall that we've made and we just start poking holes at it. And after a while, because what we need to do now is predict port 20 with any source port, we have to start opening up port 23 with any source. So you can see what I'm saying. So this device here ends up being a Swiss cheese. Everything just flows right through it again. Okay, and what you'll find is anybody on the internet that wants to hack you will go out there and they'll probe for those holes. They'll try and find a hole that they can actually exploit. So it's a very easy way for them to exploit that hole, because it becomes very difficult to predict all this traffic. Okay, the next thing that happens is this access list actually grow really fast. And that creates a bit of a troubleshooting nightmare as well. Okay, so let's just clean this up a little bit. So as you can see, yeah, it was a great start, you know, that we had in the beginning, but I don't think that is the actual answer to all the issues we have. Right, so let's just clean that up again. So what would we want to do? Well, the next thing that they said was, let's talk about firewalling for now. Right, so in a firewall, one of the cool things about a firewall is it says, well, what I can start to predict is I'm going to start creating a flow here. A very simple flow. Yeah. Let's say this is IP address 10.1.1.0. This is 10.1.1. Oh, sorry, can't be 10.1.1. Sorry, 2.0. Yep. And so let's say there's a device on here 100 and a device on here which is 100. Happy with that? This is my router firewall. Doesn't really matter at the moment. So looking at the type of traffic, let's say we're going to use the easy session at the moment. We're going to say we're going to be basically using telnet. What do we know about telnet traffic? Well, we know the telnet is always port 23. Yep, that we do know. Right, we also know that it's session based, so it's based on TCP traffic. Okay, so that's very predictable. So I also know the source IP and I know the destination IP. Right now I could have done this with an actual access list. Right, I know that, but what they've done with the new, more predictable firewalls is what they've decided to do was, what if we could only open up a packet on the inbound direction? So a packet starts from there going to that side, so from the inside to the outside. What if we could predict exactly the port numbers of the inbound traffic? Because up to this point, everything we do know is destination-based ports. We don't know the source port yet. The source port is random. So it would be more secure if I could just open a pinhole inbound for one port number. That would be pretty cool. So, okay, so let's start this. So let's say device A wants to talk to device B. Okay, just want to change color here. Sorry about that. So what's the first thing we do know? He wants to telnet session. So there's your packet. So it's going to be a source port and a destination port. I'm going to start at this level, right? Not high up, doesn't really matter. So from a source port point of view, it's a random port. So let's make it 2123. The destination port we do know is telnet, right? And this pretty much gets encapsulated and moved down the stack to the actual network layer. There we actually have a source IP and a destination IP. So my source IP at the moment is 10.1.1.100. My destination IP is 10.1.2.100. Okay, so this is pretty cool that we know this so far. And basically then they move through the MAC addressing and so forth. Right, and this packet gets fired out. Now when it basically hits this adaptive firewall slash router with firewall functionality, what this device does, instead of opening up all the ports for the source port, he can now predict when the traffic comes back, the packet should look something like this. It's going to have a source port and destination port combination of 23 and 2123, yep, and a source IP of 10.1.2.100 and a destination IP of 10.1.1.100. So instead of waiting for the packet to come back, this guy predicts that that's what's going to happen. That's what the packet should look like when it comes back. He then goes and basically opens a pinhole in this inbound direction, a pinhole for only this one packet based on this criteria. When the packet fires through, packet is acknowledged, everything depending on basically TCP setup and so forth. If that comes through, packet is acknowledged. Based on the type of flow, this would either stay open for that session or the session would drop. Right, and that panel would be closed. So you still have that hole that comes in, but now the hole is really small and very hard to hit. Because if you were going to come in from the outside in, right, and somebody tries to hack through this network, what they're going to try and do is they still know that 23 is a well-known port, but to hit all the actual source port combinations with 23, it's going to be much more difficult. Right, and that is why we basically have this adaptive firewall. It changes based on the requirements on the outbound traffic. Now what you do need is you need a trust zone and an untrust zone. Okay, so you normally move from trust to untrust. So the way we're going to do this in the configuration later on is we are going to actually create an access control list, advanced 3000. We're going to say deny IP any coming from anywhere, and we're going to bind it inbound on this port. So by default, if anything from the outside tries to get into this environment, it basically denies the packet. So nothing can start a session from the outside in. If you wanted a specific device to be able to create that out to in, you would have to open up a hole here for that. You would basically have to open up a place for it to come through in the access list. But for now, we're not doing that. All right, we're saying that we're only trusting in to out traffic. Right, so as the traffic moves through this environment, now you need to do something else. You have to somehow trigger this device that is now looking at packets, and it's got to build this ASPF. We call it ASPF, right? Table. It's got to somewhere keep a record of this information here based on the interface. Right, so that is basically what we call an ASPF policy. Now inside the ASPF policy, I'll show you how to set that up. We are going to do a couple of things. You're going to basically detect traffic, but you don't want to detect all traffic necessarily. Okay, so you get different types of traffic. You get transport layer traffic, that's TCP and UDP. By default, you want to inspect all of this because you're going to have TCP and UDP traffic flowing in this network. Otherwise, I don't know why you have it. Right, the second thing you want to do is you want to basically detect, this is one layer up. TCP, UDP is where? Layer 3. Right, layer 3 and layer 4. Right, layer 3, layer 4 touches on both of those. Detect application. Something like, let's call it for now, FTP. Right. FTP is a little different. It's got a funny type of way of working. If you do application like H323, right, DNS, those are specific application type traffic. Now, if you think to yourself that there's a reason for this guy to FTP out of this network, you have to enable the FTP application. Right, the simple reason is that FTP, right, works slightly different to your normal standard TCP type traffic. Okay, in TCP, the predictability is based on the three-way handshake and, of course, the way that TCP works, as well as UDP. But with FTP, things are slightly different, and I'm going to discuss that now. So you also can detect your basic transport layer. You can also detect your application layer. Now, this one is on by default. This one you have to switch on based on the applications you are running at that specific time. I think I actually have a session running here. So if I draw this in, there it is. Okay, then I can actually show you this. Okay, so system, and what you would do is you would say ASPF, policy and a number, for now 1, and you would say detect, question mark, and those are your applications, DNS, FTP, GTP, you see HTTP and so forth. Okay, those are specific applications. So my big thing is what you would say is, well, why don't you just switch it all on? Well, the challenge with all of this is, if you switch it all on, there's a cost of CPU. Because for every single DNS traffic, for every single FTP, it's going to go deep, measure, and check it all out. So be very careful what you switch on, switch off. Yep. So by default, that is not switched on. What you will see is that there is no detect TCP and detect UDP because by default it is switched on. It does that at the transport layer. Good. Then of course what we also have in your question mark here, you basically have a couple of things we can do here. I'm not going to go through all of this, but you have basically the detect coming in there. Yep. So we'll also look a little bit later at Icmp. We can actually talk about that as well, because by default, you have to look at the Icmp error request, and you also have some type of TCP issues. Right. If I remember correctly, that should be a Tcp Syn Check. Okay, Syn Check. So effectively what a Tcp Syn Check does, what they'll sometimes do from the outside in is they'll send a lot of Syn packets, and they expect the router to do Syn X, or some device on the inside to do Syn X. So what you're going to do is you're going to do a TCP Syn Check to make sure that somebody is not flooding from the outside in to actually utilize all your memory. Right, and that TCP Syn Check is as simple as this. Right. Icmp Error is the next one we normally do. Well, based on Icmp errors from the outside in, right, if there is an error, don't try and respond back to it. Okay, what you do is you just literally drop the packet. Okay, and if you do a display this now, you'll see basically that it's there. And then of course I can do the detects. Detect, let's say, FTP. And we have some actions based on that. Well, what if I have the action there? What do I want to do with it? Drop, I can do whatever I want to with it, and so forth. So I can have different actions here. Yep. Good. So that was just a very quick show of what we can do with the commands. Okay, so as you understand right now, we've now covered a couple of things. I quickly want to talk about the FTP and applications, why it's a little different. Okay, so basically what happens with FTP. FTP is a funny little protocol. Okay, it's like some of the actual applications we do now. If you have a device talking to another device, forget about routers and everything in between. Right, let me just quickly open up this one there. So effectively what we want to do is we want to basically look at some type of application that is different to the normal flow. Alright, inside that what you'll see is with a stateful firewall there's a single channel protocol and a multi-channel protocol. Okay, a single channel protocol we spoke about a little bit before. It's things like HTTP and so forth. Alright, we can predict the users and the recipient's destination and source ports. That stays pretty much the same way. And effectively what the single channel means is from the inside out. Okay, so all the session initiation is from the inside out. When we start to talk about multi-channel protocol, there's more than one connection, and one of those connections can be from the outside in. Now what we've said before is that we're not allowed to create an outside in connection. Now that's a multi-channel protocol, right? Things like FTP use multi-channel. Okay, so I'm going to quickly show you that as we go through. So effectively, let's say this is FTP, and we say this is, sorry, that's the wrong side of it. This is 10.1.1.1 going to 10.1.1.2. Doesn't really matter. I'm going to basically go and FTP right to it. Effectively, the first packet says that my destination port is going to be 21, and my source port is random port 2142, whatever the case may be. A packet fires out to the other side. If it receives the packet, the server receives the packet. What basically happens now is it sets back a control packet. And it says that we're going to, this is just a setup R21. This guy then says, I'm going to go and say destination port 20 and random port XYZ. Right. And it starts basically a packet inbound. Oh, sorry, that was just my mobile. Okay, it basically then sends a packet inbound. So what we want to do is, remember what we said with the firewall of the device inside here, forget about the IP addressing right now. It will basically block that packet from the outside in, out, right? So what this device needs to start doing is it needs to start inspecting this flow, because inside this setup flow, this traffic data will be transferred. So what he'll do is, he'll actually open up a second channel from the outside inbound. Very important. Okay, but what needs to happen now, think about from a processing point of view, is that this device here, router, firewall, doesn't matter, needs to start inspecting this flow at a deeper level, because somewhere inside this negotiation, this data right, there's going to be some controlled traffic that he needs to look out for. Once he receives that data, he can then open up the appropriate channel. That's multi-channel traffic. That's more application type traffic. Like I said, be careful when you do this, because looking into data equals, the cost of that equals CPU cost. Okay, so just a warning. This is for all makes and models out there. Right, so effectively that's what we're looking at from an FTP, an actual multi-channel application point of view. Good, so we've now touched on your multi-channel, we've touched on your different types of firewalls that you do get. The next thing that they found and they're looking at the moment is that you look at your zone-based firewall. Zone-based firewall. Well, what is inside, what is outside? Well, if there's a firewall out here and it has multiple places, right, so it's very easy if it's just connected on the inside to a LAN and on the outside to a WAN, right? And this WAN more specifically is World Wide Web. Well, it's very easy. This is trusted, untrusted. But what if I had multiple LANs here? Yep. Well, a couple of things needs to happen. Well, one of those LANs, let's say, is the financial bit. And you don't necessarily want people to go this direction there. That's not good. But you don't mind these guys talking to each other. That's all right. And you don't mind them talking outbound, right? But this guy talking outbound is different to inbound. Then you could also have a DMZ. To make things easier, what they've done is, inside this device, is they've created zone pairs. So when you talk about a zone pair, you talk about any one of these interfaces associated with a zone, right? Associated with an out, we'll talk about in, out traffic path. So anything coming from these two interfaces going outbound on the World Wide Web, all right, is called a zone pair. Now I can apply an ASPF policy to a zone pair as well. This becomes very helpful if you have a larger type branch where you actually have different types of traffic. Okay, one of the cool things about this is by default, if you actually have a zone pair, right, or you create up zones, and you, let's say, have a LAN infrastructure, right, what you could do is you could basically turn around and say, okay, well, traffic flowing from one zone to the next zone would be permitted, but not the reverse of this. And traffic flowing from this zone outbound would be permitted, right? So that what we can say is, and basically inbound as well. So this turns into a DMZ, demilitarized zone. Inside this DMZ, you, for instance, put your World Wide Web server. So traffic is allowed to come from the outside in, hit the server, right? But this server, what we are saying is not allowed to initiate traffic. It's not allowed to initiate traffic from the DMZ to the LAN. You can, however, access from the LAN to the DMZ. Brilliant. Okay, so that's a way to make sure that people can't hairpin. They can't jump onto this router and then from this, oh sorry, not router, device, and then from this device jump into your network. And that's how we use the zone pairs. Okay, and that's a zone-based firewall. So what I can tell you today, right now, I'm not a marketing guy, but what I can tell you is if you actually own a router from HP, right, and you have the latest code on it, effectively what you'll find is that you can actually set up a couple of things. You can set up the packet filter firewall. You can set up the active, right, security firewall, packet filter, the active secure packet filter, sorry, and you can also use zone-based firewall. Right, so that's pretty cool. You can decide which ones you want to use. A customer recently came to me and said, well, I've got a bunch of these routers installed. Do we switch them on? I said to him, well, there's no cost associated with it, so go for it. And they've actually switched it on. It's a financial. Okay, so the one thing that we do see with these firewalls, please don't make that your final point of trust. Right, just be very careful that these firewalls have a definite place to play, but to actually manage them becomes a little bit more critical, because they can't send up all the types of attacks they're getting, because they'll flood your network, the WAN, with that type of traffic. It's just another level of security that you want to look at. If this is a very big branch, I still suggest that at some point you actually put a firewall in place that's designed to do this, depending on the amount of data you want to push. Right. Okay, and that brings me to the the end of the first video that I wanted to talk about is just to give you an idea of what we'll be talking about. So of course, as we go into video 2, 3 and 4, we'll be touching on these different ones. I'm not going to set up a packet filter firewall. I'll just show you inside the ASPF demonstration when we actually set up an active firewall. I'll just show you what a normal packet filter firewall would have looked like a little bit, and we'll do some demonstrations and tests about that. Okay, and with that I want to thank you for your time, and please come back soon for the update videos. Cheers, bye bye.